Now, it was a bit of a shock to realise there was no PA. Can everybody at the back hear me okay? Whether I managed to shout at this volume for that length of time, I don't know, but as I was saying to Doug, I used to be a riding instructress. That was a while back, but I'm used to shouting at lots of errant children, so hopefully this will be all right. So what follows really are my views on what soil health means, why we're in such a mess at the moment in some parts of the UK. I'm going to touch on soil health measurement. I'm not going into that in a great deal of detail, mainly because I feel I've talked it to death at AHDB events over the past couple of years. And probably soil health measurement is a very big topic, but we can cover that in discussion. And then I'm going to, because there's plenty of time for questions. This is a fantastic design of conference, I think. So many conferences have too many speakers and not enough time for actual debate to hear from people in the audience. And this is clearly not like that. So I'm looking forward to the debate myself. Then I'm going to be speaking a bit about improving and maintaining soil health. First of all, we do have to define it. There's lots of definitions of soil health. A lot of people feel it's really just a biological thing, but it is a biological thing, but it's so much more than that. So it's been defined as the capacity of soil to support productivity and ecosystem services, but I feel that's too narrow. I like the Doran and Zeiss definition, which is saying that it's the capacity of soil to function as a vital living system, not just to produce crop yields, quality crops for us, but we have a responsibility as well as land managers and farmers to make sure that what we are doing doesn't affect the wider environment. So our soils have got other jobs as well. Basically, they've got to maintain wild plant and animal life as well, and also protect the environment round about the farm. Without good soil health, soils are going to fail to deliver optimal crop yields. We'll see crop quality declining as well, and we'll see increasing practical and environmental problems, and that's exactly what we're seeing. We've got a crisis, there's no doubt about that. I think everybody in this room acknowledges that, otherwise you probably wouldn't be here. We've got clear evidence that soil health is declining in cultivated soils. Can I just check at the back, everybody can hear what I'm saying okay? Yep. I would suggest if you can, if my voice starts to pack in, which is not impossible, come further down here. So what are we actually seeing? We're seeing low organic matter content in cultivated soils and soils with very poor resilience to stresses. When I started to, or when Earthcare technical staff started talking about soil health about 15 years ago, we were getting very few people coming along to meetings, and as little as 15 years ago, we were asking AHDB for some money to look at methods for measuring soil health and measures to work on measures to improve it. And we weren't quite there. And literally 3 or 4 years later, something happened. It was one really wet summer. That's what made people start to notice. And that's quite often the tipping point for individual farms. It's a really wet summer, or perhaps it's a really dry period, and suddenly you realize you've lost control. So we were seeing low organic matter in cultivated soils, soils with very poor resilience to a range of stresses, decreased porosity. I've always been interested in soils. I've always been passionate about soils, and even as a wee girl I remember driving around certain parts of the Carsagowrie in Perthshire, driving up to Aberdeenshire past the Howe of the Mearns, and you wouldn't see soils that were flooded in winter to the extent that you do now. Far, far more, and I'm sure everybody here is old enough to have seen a change in their lifetime, where you see far, far more flooding in soils, in ponding in fields in winter now than we used to do. There's a lot of reasons for that, of course, but we're seeing low levels of biological activity and needs for increased tractor power. There's no doubt that the problems are worst in stockless, arable areas in England, but we're seeing it in Scotland as well. Far less of a problem in general in mixed farming, and far less of a problem on the west side of the country where the livestock farming predominates. It's much more an arable problem. Lots of farmers have become used, particularly since the 1950s, they've become used to a problem being solved by one solution. So we get one disease, for example, then we spray with one pesticide, or one pest, then we've got a pesticide, or we've got perhaps a prophylactic program to look at disease control or pest control. Or our soils run low in potash, we get it out of a bag. But this time it's much more serious. We can't really buy a quick, easy fix. And this is the sort of site where we're seeing more and more horrendous soil damage. This didn't happen overnight, obviously. I mean, we realise that. So why has soil health declined? Well, there's been a lack of organic matter returns. And I remember when I was at college studying the Rothamsted experiments, where they've looked at year after year after year of simply supplying crops with synthetic fertiliser nutrients, thinking that, well, understanding that the crop takes up those fertiliser nutrients as very simple inorganic ions. Therefore, why is that not all we need to supply? Surely that's all we need to supply. And that was the basis behind those Rothamsted experiments, where synthetic fertilisers were applied year on year on year, and there was no organic matter returns. But back then, there was a belief that, oh, well, organic matter is less important. It doesn't really do a lot for crops. Just because the crop doesn't take up complex organic compounds, that doesn't mean to say that they're not very much necessary in soil. And now, of course, that's exactly what we're finding. There's lots of other reasons why soil health's declined on farms, where perhaps we are seeing changes in weather patterns as well, but that shouldn't be the only thing. That our soils should have been able to withstand that to a large extent. We're seeing more monocropping, and we're seeing less livestock, less mixed farming, essentially. What we've done is we've taken our soils for granted, and I think we would acknowledge that. I think the farming industry does acknowledge that. Not all farmers, but many have. And I think I've heard many farmers stand up and say, but I'm just doing what I was told to do. And that's true. Many people in colleges and universities, certainly the one I was at, lecturers were emphasising that modern farming was going to mean high-tech solutions, such as the best pesticides that were good at tackling crop disease problems, and synthetic fertilisers. Organic farming was very old hat and reserved for a certain sort of person when I was at college. And I was regarded as a bit of a nutcase for even thinking about it. Just one or two statistics. I'm not going to show too many statistics on that. I want to get onto what the problems actually are and how we solve them. But average organic carbon in soils, in arable soils in England and Wales in 1980 was 3.4%. There's been a significant drop since that. That was a paper by Webb, which was looking at a wide range of soils across England and Wales. Been a significant decline in only 15 years. And if you look at arable soils, it's certainly much worse than it would be in the soils in the West. But some soils are a lot poorer than that, with soil organic matter contents less than 1.5. There's certainly soils in Scotland like that. I was working on a farm at the end of last year, which was well inland from the coast. It should have had a good soil structure because it had a nice texture and it had been a mixed farm. Soil organic matter contents across this farm were less than 1%. Less than 1%. And yet you go to the neighbouring farm, to the left and right of that one, and they were 3, 4, 5, 6%. The farmer knows about it. He's realised a bit too late and is actively taking steps to change things. Basically, soils with organic matter content of less than 3.5% are prone to structural deterioration. I'm asked all the time by farmers, so what's my target soil organic matter content then? There's no straight answer to that. It depends on soil texture more than anything else, which I'm going to say a bit about, and also the system that you're operating, what you're trying to do to the soil. But so every soil is going to be different. Every soil and farming system is going to be different. But one thing we can say is that soils with less than 3.5% organic matter are generally more prone to deterioration. Get less than 2, and you're in trouble. We've got evidence of very severe problems in arable soils, and low soil organic matter contents are the common factor. So why is it important then? Why is soil organic matter so important? It's largely to do with the soil life. We should have billions of microorganisms per gram of soil. And it's far more difficult to actually say categorical things about this level of microorganisms is good, this is bad. So high numbers are good, low numbers are bad. That's in general true, but we don't yet have the information that we need to be as prescriptive about soil life and what it means and what to do about it. We just don't have that information yet. Soils are so complex, and only now are we beginning to realise how bad things can get when we don't have the biology in our soils. They're maybe not as necessary to provide nutrition for crops, in that you can grow crops in a hydroponic system and those crops don't need any biology at all for a short while. But growing in a soil environment outdoors where there's lots of other interactions, we have good evidence that microorganisms do an awful lot of good and fulfill a vast number of roles. So they break down organic matter, they mineralize nutrients from organic matter for plant uptake, they detoxify all sorts of waste materials that land up on the soil, either deposited from industry or pesticides that we are putting on that we want, that have done their job, and then the breakdown products are being broken down. The trouble is, I very firmly believe that if your microorganism population is poor or low or non-functional, you cannot just spray it on again. It's such a complex environment. If you put microorganisms back into the soil in the form of a spray or a potion or whatever, what happens is they usually die. What they've got to have is the right environment in the first place to make them thrive. And in actual fact, if you provide that environment to make them thrive, they'll come back by themselves anyway. So it's not something to spend a lot of money on. Got quite a lot of, done a bit of work on that, so we'll maybe get questions on it later. One thing I want to think about whenever we're talking about soil health is the importance of two really crucial soil properties. One of them is soil texture and the other one is soil structure. And I'll be talking later about measurement of soil health. And those are two properties that we very much have to measure. Soil texture is not a soil health property. You're stuck with that. So when you move to a farm or you buy a farm or buy a piece of land, there's a soil texture which that farm has, or perhaps it's got 2 or 3 different soil types with different soil textures. You're stuck with that. You can't change that. But it's a very important property to understand in detail, because knowing about your soil texture then helps you to interpret the results of all the other soil health tests that you've done, all the other tests that you've done, and then your management prescriptions should depend on that, or should take that into account to a very large extent. And then there's soil structure. And yes, you can change that in a very great number of ways, good or bad. So soil texture is the start point, and it's the relative proportions of sand, silt and clay, or gravel if you've got a gravelly soil, or even stones. Technically, soil texture is just the relative proportions of sand, silt and clay. But it can be affected very much by what's underneath. So the soil texture of the topsoil is important, and the subsoil, and also it can be affected by the amount of organic matter that's in there, which can modify soil texture. And it hugely influences all these different properties. So drainage, your ease of cultivation, compaction risk, the crops that you can grow, the extent to which the soil will warm up in the spring or not, nutrient content, liming. It has a huge impact on the way in which a farmer will choose to farm a farm. And you can do it, most people I would imagine would have a fairly good idea of how to just get a feel of their soil, but to do it properly, you would work through a soil texture determination chart. You can do it also by sending the stuff to the lab for a definitive percentage of sand, silt and clay in your soil. I wouldn't think that's necessary, but it's certainly a good idea to understand in detail the texture of your subsoils, the depth of your soil, and also the texture of your topsoil. Soil structure is something that you very much can alter, for better or for worse, and that's the way in which the sand, silt, clay particles and also the organic matter in your soil combine to form aggregates, ideally stable aggregates of between about 1 mil and 10 mils across. And it's those channels, those aggregates that will form spaces between them to allow air and water to move through. And good soil structure is absolutely vital for healthy soils, and it is one of the most important aspects of soil health, without a doubt. But I see so many fields. One of the jobs that I have done quite a bit, I was telling Doug yesterday, is go and do soil health baseline audit on farms. I'm not doing it so much now because it's a vast amount of extremely hard work, and I'm not really built for it, frankly. But it involves digging multiple soil pits across every field on the farm, and then helping the farmer to get good baseline data so that when he takes new measures to improve soil health, he can look back and say, well, this has got better, this has improved because he's got good baseline data on soil structure and soil biology and soil chemistry. I'm seeing too many fields where soil structure has become catastrophically poor, and the farmers are using bigger and bigger machines to do the same jobs that they were doing 10, 20 years back. As a very broad rule, the air and the water in the soil is crucial. You've got to be able to have air and water freely moving through the soil, and in a well-structured topsoil, it should be half of the space should be taken up by air or water, ideally 50 to 60%, whereas in a poorly structured or compacted topsoil, you're looking at as little as 20% of the soil volume is taken up by pores. And those pores are vital for air and water supply to roots, and also to all the soil life that's not plants, so things like earthworms and microorganisms, and for the water to drain after wet spells, water holding during the drier spells, and space for things to grow into, whether it be organic, whether it be microorganisms or roots. So what is good soil structure? Very, very quickly I want to go through this because it's so important. It's such an important part of soil health management and measurement. What you're looking for is crumbs and small, fine, blocky structure. Soil's easy to dig, and the roots are dense and deep. And there's only one way to find it, to look at this in detail, and that's with a spade. You cannot do it properly with any quick methods sitting in a tractor cab. It's really got to be you doing the digging. And soil is a rough surface. You shouldn't be seeing waterlogging unless in situations where the topography dictates that now and again you're on a river floodplain or whatever. But the structure forming it's a natural process influenced by management. There's no doubt that some soils are naturally better at forming structure than others. So soils with clay in them, basically, are better at forming structures than others. Sandy soil always has a tendency to be a bit looser and not so good at forming structure. But the other thing is soil smells good. So assessing soil health a bit like wine tasting, really. Some people do actually taste the soil when they're getting down on their hands and knees. I don't do that, but smell, if you've got a decent sense of smell, you can tell a huge amount about how healthy a soil is simply by getting down on your hands and knees and smelling it. Poor structure, we're seeing large beds, few cracks and pores, coarse structure, blocky structure, roots are shallow and few. Some of the soils recently that I've been digging up at the end of last year, even after a good summer, so many horizontal roots that you were seeing in there because so many of the channels were actually that way rather than down the way. Soil's hard to dig, and quite often you see a capped crusted surface, and the smell is not as good as it should be. We know what the causes of poor structure are, and right at the top in red, I've got overcultivation. So many farmers know that cultivation is bad, but they understand, and I understand completely, cultivation is necessary for some crops and some situations. There's not really a cost-effective way of producing potatoes or carrots, for example, without serious soil disruption. Heavy machinery, there are natural pans as well where you see compaction. There's quite a number of soil types up in Aberdeenshire, for example, where you've got a natural pan, really quite shallow natural pan, and that's there without anything to do with agriculture. Continuous cropping and monocropping, we know, is bad. Livestock, working in wet conditions, or livestock movement in wet conditions as well. But it's a lack of organic matter is so much exacerbating all of those things at the moment, and that is getting worse. So for a healthy soil, we're looking at a number of properties, and we've got to get the three things in mind: physical properties, chemical properties, and biological. It's all three, and you cannot have one without the other. But without good physical and chemical properties, you are not going to have the biology. It's difficult to say what I mean by, what's going on there? I'll just keep going, whatever that is. Bit odd. Sounds like there is a PA system somewhere, but it's not me. So we've got to think about organic. I've not got the microphone for that. I normally think about organic matter as a sort of chemical biological property, and it underpins the health of our soils in a very big way, but it's not going to be the be-all and end-all. Other things have got to be right. Structure's got to be right. There are so many soils in Scotland where the last thing they need is more organic matter. I've been on a couple of farms last year where there was lots of organic matter in the soil, organic matter contents of over 15%. It doesn't necessarily mean that your soil's healthy. I never am going to go down the route of believing that one single indicator is going to give us a good idea of soil health. I cannot understand how that could possibly work. So organic matter is not always a good thing. Organic matter can mean, or lots of organic matter in a soil can mean, that the soil's got other problems, which mean that organic matter is not actually being mineralized and broken down. And in the cases that I was looking at there, it was a mixture of altitude, poor drainage, and low pH. So there was no earthworms, there was very little biological activity, and the organic matter wasn't going anything or going anywhere or doing anything very useful. So you have to look much wider than just organic matter. But for a healthy soil, we need a whole lot of different parameters to be right. So good soil structure is absolutely key, but bearing in mind the texture. Don't be too ambitious. You know, some soils are going to form better structure than others under certain systems, depending on what the texture is. Field drains have got to be working, that's absolutely basic. pH has got to be on target, and the soil chemistry's got to be right. So your pK, magnesium indices, right for the rotation that you're growing in, and your soil trace element concentrations about right too. Good soil organic matter content, bearing in mind all of that I've just said, and also a functional population of bugs. But you're not going to get that unless everything else is right. So it's more important than ever to be able to recognise the importance of soil health and actually manage it for the better, because quite a lot of people, or the industry as a whole, with many exceptions, has let things get out of hand, and soil health across the board is poorer than it should be. But in order to be able to move forward from that, we need to know where we are. In other words, we need good baseline measures of soil health and soil quality. I use the two terms interchangeably, soil health and soil quality, and quite a few scientists have done that. But I prefer the word health because I think it acknowledges the importance of biology in the whole thing. So we've got to be able to measure soil health. How best to do that? Well, there's no single method which gives one useful answer. I'm absolutely convinced of that. I know there are projects out there that intend to talk about gathering all the information and putting it into a single index that gives you an idea of how healthy your soil is. But and I know some labs are offering a soil health test suite. I've not got shares in NRM, but I know that NRM do it. And I like what they're doing. I don't like it for Scotland, but I like it for England the way that they're doing it. Because it's a different, they've not adapted their test for Scotland at the moment. But the index thing is pretty meaningless because it covers up the fact that your soil structure might be poor and yet your chemistry is good, or vice versa. So I just don't understand how we can be looking at one single index for crop health when crop health should be, soil health, when soil health should be based on a whole series of physical and chemical and biological parameters. So I don't believe there's any shortcuts. I think we need to look at, if you're doing baseline measurements on your own soil, you need to be looking at physical and chemical and biological methods. And frankly, although we're talking about soil health and therefore biology, the biological methods, we're not really there with them yet. So, first of all, there's no shortage. There's no shortcut to doing the physical stuff. And really, you should be getting out there yourself with a spade and digging. And if you don't know how to do it to best effect, there's a few really good practical soils people out there who can help you do it, and maybe once, and then you'll be able to understand how to categorize a soil pit and describe a soil profile yourself. Many people can do it anyway, but you should be able to understand the texture, understand the nature of compaction, if there is any, where it is, why it might be occurring. Chemical indicators as well, so extractable pK, magnesium at an absolute minimum. Many people are also looking at base cation saturation ratio, so that's the Albrecht method type thing, and variations on a theme. I'm not against that. I also don't believe that it's the only way to go. Some farmers swear by it and are definitely getting really good results by using it. Others seem to do very, very well without it. There's a very good article in, I think it was in Potash Development Association News by Johnny Johnson, who gives a very good case for why it's a whole load of rubbish. But I think in the right situation it can do quite a lot for some farms. So chemical indicators, there's no right and wrong way of doing it, but you've just got to be aware of what your soils are, how well your soils are functioning for the crops you're growing, and you certainly need to do the basic soil chemistry tests. As far as biological indicators are concerned, there's a number of them out there. Some of them cost a fortune, and a lot of them are still at the development stage. So I would say soil respiration is one of these. We at Earthcare, for a while, were selling a kit which you could look at soil respiration with. I still use it. But the results are broadly give an idea of how biologically active your soil is. And it's not bad, but it's not perfect. It's a good thing to try, and it's cheap, relatively cheap. I think it's about £25 a test or something. But you compare and contrast that with something like the Soil Biolab test, where they categorize all the different all the numbers of organisms in your soil, and also the types of protozoans, fungi, bacteria, actinomycetes, and they tell you how healthy your soil is in that respect. But we don't really know what it means. And we can't really use that information yet to say, this soil's healthy, that soil's not, therefore you do this, this, and this to that soil, and this, this, and this to that soil. We don't have that information yet, and there's very little scientific proof that those biological measurements tell us anything meaningful, even with the soil respiration, which is quite a well-established test, and it's used by NRM as part of their soil health test suite. Earthworm counts as one biological test which I've used quite a lot, and I do believe it's useful, but it's very time consuming. I've done it for a few clients, and I think I've had my day with earthworm sampling. Because if you're doing it on your own on a windy day, you spend most of the day chasing buckets across the field rather than actually counting earthworm numbers. It's very hard work, and you really have to be doing it in such a way that it's repeatable, so the same way every time. But if you do it on your own farm, you can certainly learn quite a lot from it. Particularly if you're going from something like, if you're going from cultivation agriculture to reduced tillage or min-till, it's almost guaranteed that you're going to see a difference in earthworm numbers, which if nothing else will cheer you up. Yeah, that's just saying that get help if you need it. There's some good guys out there, but actually a lot of the really good soil scientists that I've used in the past to categorize soils and help me on in my work are probably in their 70s or even 80s, and the universities are not teaching soil science in the way that they used to. I don't think there's a degree called soil science in the UK anymore, so you're going to have to do it for yourselves, because there's very few really, really good practical soil evaluators out there at the moment. And certainly British Society of Soil Science knows that, and they're training some young people, and there's some really excellent ones coming up now. So only if you get good baseline measurements of a range of soil health parameters in all of your fields can you actually measure the impact of what you're doing, so your changes over time. I would say very strongly advise spend as much as you can to get really good set results. And if you haven't done that, do it now. Certainly use the proven methods, and if you've got enough money to be a bit more radical, then try some of the biological methods as well. That's what we've done that on a number of farms now. Use Soil Biolab to actually look at the microbiology in some detail. And James Hutton's doing some fantastic work on this as well. The Institute in Scotland and SRUC through AHDB and other research projects. So what about improving soil health? Well, all farmers can learn from some of the work done by organic farmers and some of the mistakes made by organic farmers. I'm seeing at farmer meetings more and more conventional arable farmers using methods, talking to organic farmers for a start, conventional organic farmers speaking to one another much more than they used to do, and many of the conventional farmers are using methods which some of them I remember in person were laughing at the organic farmers who were doing it before, and here we're seeing them doing it now as well. So arable farms where there were no grass clover lays, I'm now seeing grass clover lays, green manures, cover crops, even intercropping in some cases, a bit of agroforestry in some cases where there's trees actually coming into arable fields or hedges being replanted, and herbal lays and so on. If it's even reached the archers, as I'm sure some of you'll be well aware. So, and there's much more discussion going on between conventional and organic farmers, which has got to be a good thing. But we still have a huge amount to learn, I feel. Modern organic and sustainable farming has got the potential to be so much more than what organic farming used to be, or what pre-First and Second War farming used to be. There's so many modern technologies that we can bring in. And for, I think, 3 years I worked with a guy called Carlo Leifert, who now is Professor of Ecological Agriculture at Newcastle. But when I was at Aberdeen University, Carlo got a huge stack of money from Tesco, of all people, to look at development of organic farming methods for broad-scale agriculture. And it was at the time where organic farming was really moving from niche to more mainstream. And Carlo used to say that, you know, if all the money that the agrochemical companies had spent on research over the years, if that amount of money had been ploughed into organic farming and sustainable farming, we would be in a completely different place now, and we would be in a much healthier situation. So many people say, oh, organic farming will never feed the world, and sustainable farming can't produce the crop yields that we want. Absolutely it can, The problem is so much of the money that has been spent on agriculture has not come from government, it's come from companies who are going to be selling you the products that the research has been done on, which is fair enough and it's completely understandable, it's not wrong, it's just that we've got a lot of catching up to do. So there's a lot to gain from potential advances in modern science to help us better understand how to manage our soils. So we need methods to better understand the very, very complex interactions between different aspects of farming systems and how to understand the importance of the different forms of organic matter in soils. And I think that's really, really important. So in some of the Scottish soils on the west side, we've got very humified organic matter, which is not actually doing a lot. It's very, very old. The pH of the soil is low. It's also the soils are poorly drained. It's not functioning as well as it could be. Whereas what we need, we reckon, in arable soils is for organic matter of a blend of ages to be present in the soil. So you've got that very, very important, finely humified organic matter, which helps to build soil structure, and it helps to glue the aggregates together in themselves and between the aggregates, and it helps to provide positively and negatively charged sites for nutrient ions to sit on. So in other words, it increases cation exchange capacity in sandy soils, but you also need that fresh organic matter, regular small returns of fresh organic matter, and that because that's what the earthworms eat in order for them to function properly, and that's what the microorganisms need for their food. So we need not just organic matter per se, but we need different forms of organic matter, different ages. And we're not good at categorizing that. At the moment, the only test that's widely available in commercial labs is loss and ignition, or a modern version of the Walkley-Black method. These are blunt tools. We need much better than that. They're also very slow to change. So if a farmer was really excited about putting compost on year in, year out, and thinks 4 years down the line, what's my soil organic matter by loss and ignition now after 4 years of compost addition, tested it before, tested it after, hardly any change. Because it can take many years for a change in that property, soil organic matter by loss and ignition. But there's other better methods, and we've been banging on at the labs for a number of years to try and commercialize some of those methods and then put them out to farmers to say, this is a better method for looking at the changes in soil organic matter, which are going to mean that they're an early indicator of long-term changes in organic matter following implementation of a new management regime. So there are methods out there that do that, but they're not really commercially available. So there's no one quick fix for poor soil health. I don't believe there's not. There's a slightly worrying propensity in one or two places for where people believe, or perhaps where salesmen are saying, well, if you buy this, this is this thing you want to buy out of a bottle for increasing your soil biology or improving the health of your soils. I'll speak a bit more about, but by that I mean biostimulants of various sorts. I'm not saying they're all rubbish. Some of them are very good. Some of them have proven good effects, useful effects, but there is no one quick fix for soil health improvement. I'm absolutely convinced of that. And the other difficulty is there's no one recipe of multi-point solutions to fit all sizes or to fit all farms. It depends on your soil texture. It depends on the farming system, what you're trying to grow. It depends on your latitude, your altitude, your topography, and also what the history of your farm has been. How bad is it, in other words? So I would say success is likely to lie in really good baseline testing to establish where you are, ongoing testing to measure progress, very good record keeping, and that's what separates the movers and shakers in this area, I think, from the people that are not quite sure where they're going. Some guys have got really good baseline records and they're constantly recording where they are and recording their progress. Just simple things like crop yield, weather, any funny things that happen. Was the crop yield very, very good, but the quality was poor, and in what way? And simple things like how much fuel they use, perhaps, for cultivation. Not everybody does that, but it's worth doing. And the other crucial thing is learning from others and sharing what you learn. Organic farmers have thought about this type of thing for a very long time. They understand there's no quick fixes. They don't have access to single point solutions like synthetic fertilizers or pesticides, and they have to think more creatively. So they think in terms of the crop and soils and the whole rotation, and about all the small things that they do. And what they end up doing is choosing a whole range of partial solutions, if you like, to potential crop and livestock problems. And I say potential because they have to think in advance, because there's no reactive quick fixes in organic farming since synthetic pesticides are banned. So they're used to thinking in a systems way, or in a holistic way. And I would say in terms of soil health, that's how all farmers need to think. So as far as actually improving soil health is concerned, most useful strategies to enhance and maintain soil health aim towards building and maintaining soil organic matter. Now I would still say question that in your own head. Probably not down here, but I know that here in this room there are people from all over the UK with all sorts of different soils. I would question absolutely everything that I hear from anybody, particularly somebody that's trying to sell me something. But here, I would question it because there are soils out there which have got plenty of organic matter, and that's not their problem, soil health-wise. Their problem might be altitude or topography, which you can't change, or it might be poor drainage, for example, or extremely poor soil structure. So it's not always organic matter. But I would say for most arable soils, you're going to be doing some good, if not a lot of good, by enhancing your soil organic matter content. So there's lots of ways of doing that. So I've put that as number one, really, in enhancing soil health. How would you do that? Well, there's lots of ways of doing it. The obvious way to do it quickly and to achieve it quickly is to put bulky organic materials on. So by that I mean dung, straw, cattle manure, compost, paper crumble. That is one of the quickest ways of achieving an increase in soil organic matter. But it is expensive. And at the moment, the cost models associated with using compost are mostly based on the things that is easy to quantify. So what's the value of the P and K and magnesium I'm getting? What's the value of the liming, if there is one, for this bulky organic material? And maybe even sulfur and trace elements. But that's how far most people go. It's extremely difficult, and I've been trying to do it recently, and there's no ways of easily doing it. How do you put a value on the organic matter that actually gets into the soil? It's a very difficult thing to do, because you can't assume that all the organic matter that's in 20 tonnes per hectare of compost is going to stay there, for example. If you're regularly cultivating it, you'll lose a proportion of that as the years go by. Very difficult thing to do, put a value on it. But the other thing is many farmers just do not have access to bulky organic manures in the form of animal manures or composts. And they've got to look at other things. One thing which some farmers are doing actually in a very small way in this country at the moment is planting, so going into agroforestry basically. And this is very experimental at the moment, but what they're doing is planting things like short rotation coppice willow with a view to taking that organic matter, chipping the wood, composting it, and then reapplying it to land. Now, how that's going to be cost effective, I can't imagine. It smacks of desperation to me, but maybe they are desperate. I don't know much about those farms concerned. But another surefire way of improving soil health is by trying to return as many crop residues to the land as possible, including straw, for example. And this year we've seen a lot of farmers, despite good straw prices early on, returning straw back to land. I'll say a bit more about that in a minute. Also, green manures and cover crops, wider rotations, fewer monocultures. I'll say a bit more about that in a minute. Use of livestock in the rotation. Reduced tillage, that's obviously a big one. and biostimulants. I've put a question mark at the end of that. Mentioned this already, about 18% of the organic matter found in arable topsoils in 1980 had been lost by 1995. Pretty scary. So what we're trying to do is put it back. And there's lots of evidence that when we do put it back, we're starting to see improved structure and workability in our soils, increased water holding capacity, better infiltration, in other words, the water's draining through the soil profile better, increased biological activity, improved retention of nutrients, and improved turnover of nutrients, so less losses of nutrients to the environment, in other words, and greater resilience, not only to dry weather conditions, but to all other stresses as well. There's lots of very clear benefits to putting soil organic matter back into the soil. Better crop establishment, increased crop yields, reduced fertilizer requirement. But what we've always got to bear in mind is that all the measures that I'm talking about cost money. And at the moment, I'm not aware of I think it would be extremely difficult to be able to put a good cost-benefit analysis, hard figures on some of those measures. I know some people are attempting to do it at the moment, but of course every farm's different. I want you to think about bulky organic manures for a minute, bought in or farm-produced ones. Some are basically just fertilizers. They're not organic matter builders, whereas others are both. So I've heard a lot of rubbish talked by digestate plant salesmen, AD plant salesmen, for example, and also some AD plant managers who are saying how good digestate is for organic matter. No, it's not. Whole digestate is not a good soil conditioner. It's a fantastic fertilizer, but there's very little solid material in it apart from anything. So these materials like slurry and cattle slurry, pig slurry, whole digestate, and even more so liquid digestate, they're basically fertilizers. If you can put them through a band spreader, then they'll have 4-5-6% dry matter. So think how much organic matter is going to be in that, not very much. So this slide here basically shows you if you were applying those organic materials at the NVZ max, in other words, 250 kilograms of nitrogen per hectare, then it shows the right-hand column how much organic matter you'd actually be applying. So strawy cattle manure is right up there at the top. Green compost and green food compost, they're pretty good as well. What that doesn't say is how much woody material is in those materials, and therefore how long-lasting the organic matter is going to be. So in fact, composts are a particularly good source of organic matter because it contains a lot of lignin, which is very long-lasting in soils, whereas the organic matter in the other materials tends to break down more quickly. But it can be quite a big expense to buy in something like green compost, for example, whereas many farmers would find it easier to be putting in, to be returning their own straw back to the soil. And that adds a fair bit of organic matter, and of course P and K as well. I've put down at the bottom there whole digestate. Yes, you could put on 1.4 tons per hectare of organic matter there, but in fact whole digestate is not, that's putting the whole digestate on at 45 cubic meters per hectare. I'm not a fan of doing that because quite often it can end up not having a very nice impact on earthworms. So I prefer to see a really, really ammonia-rich digestate going in on at half that, maybe more times in the year, say 20 tons, 20 cube per hectare, 25 cube per hectare, most 30. And still I would be feeling my way along and seeing what's the weather conditions like, what crop am I putting it on, can I do this in 2 applications rather than one? Whole digestate is not a good soil organic matter builder. I would also say neither really is poultry litter well, yeah, let's stick with poultry litter because there's so much nutrient in it that you wouldn't be putting it on at high enough rates to add lots of organic matter on a regular basis. So the real organic matter builders are paper crumble, dung or strawy cattle manure, and composts. Crop root residues, somebody in this audience might recognise 1 or 2 grains of straw from this soil profile. Crop residues can return varying amounts of fresh organic matter to soil, and it can be done every year if you want. And basically the more the soil and its microbial population get used to having great big dumps of high carbon residue every year, the more they can cope with it, and the less problems you'll have with nitrogen immobilization from very high carbon residues. So in an 8 tonne per hectare wheat crop, you might be returning somewhere between 6 and 8 tonnes per hectare of straw. So it's 3 to 4 tonnes per hectare of organic matter. If you're doing that every year or even every couple of years, that's going to be significant. But the other thing about it is it's this important thing of fresh, regular returns of organic matter. That is, I believe that's extremely important for soil health, and almost better than one massive dump of dung once every 5 or 6 years. There's some pretty good evidence, I mean I've just put one example there, but there's some pretty good evidence out there for the financial benefits of returning straw to the land rather than ploughing it down or leaving it on the surface, rather than harvesting it and selling it. But it doesn't take away from the fact that you've really got to do your own sums based on your soils, your P&K status, your soil organic matter content, and the price that you would get for your straw, for example. Just one thing to put in briefly here. In many ways, the best soil organic matter builders will be those with the higher amounts of woody material or papery material, in other words, high carbon to nitrogen ratio materials. The problem with that is that the very high carbon materials with carbon to nitrogen ratios of sort of 40 to 1 right up to maybe 400 to 1, they can lock nitrogen up and make your nitrogen management very, very difficult. And that's one thing that there's a certain amount of published advice out there, but you really need to feel your way along and see what works for you. So the rapid nitrogen release you'll see from things like poultry manure, digestates, well, less so cattle manure. Cattle manure, if it's very strawy, it's unlikely to lock up nitrogen, but it's unlikely to release that quickly either. Whereas on the high C to N side, things like paper crumble, wood chips, straw, maize stalks, even an immature green compost, they can lock up nitrogen quite a bit. But it's manageable. I'm not going to say much about this because I'm not an expert in green manures and cover crops. I'm very much on a steep learning curve. I would say that most people as far north as I am are still on a steep learning curve as far as green manures and cover crops are concerned. I'm seeing a lot of conventional farmers embracing those, helped no doubt by the subsidy regime, but the real experts in this are some of the organic farmers and the conventional or sustainable farmers that have been doing this for a while. But most of the ones that are achieving really phenomenal results are quite far south. But we've got guys up in Turriff, which is right on the north coast of Aberdeenshire, who are trying cover crops in a big way, and they're quite astounded at the benefits that they're getting. But it's very chancy up there because the growing season's so short. The key point is not to be leaving soil bare if at all possible, and that's certainly with my own soil, which is a silty loam, a very difficult soil to manage and extremely damaged every single year if I leave that soil bare over the winter. So now I never leave the soil bare over the winter, and if my cover crop fails to establish, then I put down a mulch of some sort. Usually it's clippings off the wildflower meadow, which gives me a nightmare with weeds. But leaving soil bare, particularly on soil types with silt on them, is a really bad idea. Obviously, you'll need to choose species which suit you, and the best examples I'm seeing are where people are working together locally to work out what actually does well in their own area. There's a lot of good information out there from some of the seedsmen as well. And some really good AHDB publications on green manures as well. From my point of view, slightly English-centric, but in that they say a lot of the stuff which is really not so applicable to people as far north as where I'm from. But they're very good publications, and they've got some excellent, clearly written stuff in them. Wider rotations, well, there's a widespread sort of embarrassed acknowledgement that monocultures are a bad thing for soils and for biodiversity in terms of microorganism biodiversity, plant, weed biodiversity, and also larger soil organisms too. By growing, this was a crop of, it was not cannabis, it was a crop of fibre hemp, which we grew in Aberdeenshire when I was involved with the Centre for Organic Agriculture. And that just grew a phenomenal biomass exceptionally quickly. And we couldn't, for various reasons, we couldn't sell it. I had difficulty getting the license for it because it was in a field in the middle of nowhere, but it was about a quarter of a mile from Dalcross Airport. And that's classed now as an international airport. So they thought I was going to grow this stuff, buy it and bulk it into bags and then sell it in some dodgy way via the airport. So we ended up having to plough it in. But what a biomass from this crop. So anyway, the point of that is growing different crops in a rotation, and also in some cases at the same time, soils get a chance to recover in a way from the deleterious effects caused by a single crop species. So some crops are poorer for soil structure than others due to the intensity of cultivation methods, potatoes, for example, or carrots. And some crops encourage the increase of certain types of pests and diseases. And some crops bring particular benefits. So it's really just a balancing act. It's known that this works well in terms of the soil, but obviously it's got to work well financially as well. So there's a lot of calculations to be done there. Use of livestock, there's no doubt that mixed farms tend to have fewer problems as far as soil health is concerned, and declining soil organic matter. Many farms that we've been measuring at Earthcare Technical, there's a broad difference. Stockless arable farms have poorer soil health than those with access to livestock. But it's far too big a step for many arable farmers to go back to putting, they've got no fences, let alone stock experience, and the nearest livestock's a very, very long way away. So for most farmers, this is just not going to be a way to go to return to livestock farming, even though we know that it might well work and work really well. But there are some cases, some experimental cases. I was speaking to Edwin about this last night. I cannot believe this is going to be an economically feasible solution, but some arable farmers are kind of rent a farm. They're almost renting the whole system. So there's livestock guys coming across from further west with the handler or livestock manager and the fence and all the livestock, and they're basically mob grazing off cover crops and short rotation grass, and doing all the management for the arable farmer, so the arable farmer doesn't have to get into livestock in any way at all. It's experimental. Is it ever going to be economic? I don't know. Reduced or no tillage, I'm a huge fan of reduced till and no till in some cases. But it does seem that there are some people out there who almost seem to think it's some kind of a religion and think it's the only way. I don't believe it's the only way. And we've seen a number of situations where reduced tillage is working really badly. We've seen quite a lot of crops fail because the farmer's gone for it too quickly, perhaps. His soils are not ready, or he's maybe not got the right experience or the right machinery or whatever. I think there's no doubt at all that cultivation's generally a bad thing for soils. But for you to move towards reduced tillage, I think sometimes you have to do a really good estimation or investigation of soil health first, see where the compaction is, if there is any, and relieve it first, and perhaps have some years where you're reintroducing organic matter right through the soil profile to start with, And also some soil types are much better suited towards it than others and will adapt much more quickly to reduced tillage. So I think it's the way to go, but I don't believe that it's necessarily the case that you should rush towards it all guns blazing until you've really established the right way to go for it. Yeah, I've said that there really. I want to finish this bit talking a bit about biostimulants. There's two broad types, the non-microbial ones and the microbials. And so by non-microbials, I mean things like seaweed extracts, humic substances, chitosan and the sort of things from shellfish, basically, chitin-based products, anti-transpirants. And then there's the microbials themselves, plant growth promoting bacteria, arbuscular mycorrhizal ones. There's quite a bit of work being done on that just now. Non-pathogenic fungi, and then compost teas. So what can they actually do? Well, some biostimulants are associated with increased crop nutrient uptake and also increased tolerance to pests and diseases. And some of them might well, if you're lucky, increase plant growth and yield. But when I was at AUCOA, the Centre for Organic Agriculture in Aberdeen, at Aberdeen University with Carlo Leifert, we were given so many portions to test, and we were lucky enough, Tesco was paying us quite a lot of money, we were lucky enough to have a really good band of keen research students and postdocs. So we did quite a number of fully replicated scientific trials, independent trials, on a whole range of biostimulants, things like garlic extract, different types of humic acids, chitin-based products, seaweed extracts, and I'm afraid to say that the great majority of them didn't result in a significant increase in yield. Now, we tried them on several crops. I was quite disappointed because I wanted them to work, but some of them did, but many of them did not. So what I would say is proceed with caution. It's also worth you having a look at, this is a really good AHDB fact sheet on crop biostimulants. And this was a piece of work which definitely was needing done. It was published late in 2017, and it basically came up with the hard scientific fact, or not, about different types of biostimulant. So the red, down the left-hand side there, there's the names of the main available biostimulant products, not named proprietary brands, none of that. It was just broad material types. They told you what it was, and then if there's basically no evidence that it works, or very, very limited evidence that it works, that product for a particular purpose, then it got a red blob. And if there was some evidence that it worked in some situations, or it could work, it got a kind of a yellow blob. And if there was good, strong evidence that it worked from various independent trials, it got a green blob. Well, there's not very many green blobs. So there's only 4 green blobs there. So for the ability of some of those products to do something useful. So I'm not knocking them, but what I am just saying is don't rush for any of those things wholesale. There's no substitute for the sheer hard graft of breaking up soil compaction, getting your structure right, putting bulk organic matter back in, looking at your rotation, all these kind of things. There is no quick fix for really bad soil health, and you certainly aren't going to do it out of a bottle in any big way. And by compost teas at the bottom there, I've done years of work on compost teas. That was in the bottom in the last slide. I've done years of work on compost teas. I really want them to work, but they don't do a whole lot, really, in my estimation. I've done work on compost teas in lots of different kind of crops. And my business partner, who's a soil ecologist, Martin Wood from Reading University, he's now with Earthcare Technical, he doesn't understand how anybody could think that compost teas really could do a lot, because you're introducing a relatively tiny number of diverse microorganisms into an environment which has got hundreds of thousands of times more different sorts of organisms, all living happily in their own niche, in their own habitat. So they're going to be better adapted to the habitat they're in than the perfect blend that you suddenly introduce there in very small numbers. So again, compost teas do seem to work for some people, but they never worked for us in any of our trials, apart from in very, very limited number of situations, including ornamentals in nursery stock on leaves. But yet again, I'm not saying never try them. I'm just saying try everything properly on a small scale before going onto it on a big scale. So just to conclude, there's a couple of slides to conclude. Farmers must implement a number of long-term partial solutions in order to improve and maintain soil health. In other words, we're looking at multi-point solution here. And as I say, there is no substitute for the sheer hard graft. There's not a quick fix for this. It's got to be the hard work stuff. The problem is the ideal solutions tend to differ very widely depending on a whole range of factors. So latitude, climate, and topography are the obvious ones, the soil type, but also the history of what you've done or what your predecessors have done. It won't just be you. It'll also be what your predecessors on your land have done as well. The enterprises that you feel you have to run, and the ones that you might want to get into, the ones that you might want to stop, proximity to markets as well, and just sheer market pressures have a massive impact on what you're going to be doing. And the equipment and machinery that you've got. If you are going to go down the road of min-till or at least reduced tillage, it's not a cheap option. So there's a lot of things to think about. The other problem, sadly, is that government funding for this kind of research is really lacking, and the funding's not coming in from the big agrochemical companies because they're not making any money out of it. And that's the big problem. The solutions are largely you doing your work on your farm. So I would say that the biggest opportunity in this respect is that you as farmers get more and more involved in monitor farm projects, in some of the research work, very, very practical research work being done by the AHDB, and having local farmer groups, discussion groups where you've got benchmarking of the better farms if they're prepared to talk about what they're doing, and sharing information. And Earthcare Technical's involved in a lot of those monitor farm projects in Scotland. Some of them are Farm Advisory Service ones, so that's SAC's involvement, and some of them are AHDB. Some of them are really beginning to learn things and achieving things. There's massive farmer involvement, and I think you've got to do that. You've got to take it into your own hands, really. So measuring soil health is very complex. There's no single method that's going to give you an index that will tell you all what you need to know. So you've got to use this mix of proven physical, chemical, and biological methods. I would say it's worth adding some of the more novel soil biological tests too, and things like Albrecht, but don't just spend the money. Keep the records, think about what they mean, compare your results over the years, and ideally compare your results to other people as well. And the other thing is, as far as managing soil health is concerned, there are several proven methods work really, really well, and unfortunately, the ones that really work are all the kind of hard work ones. So like subsoiling to break up compaction pans in the right conditions only, obviously. A bit of cultivation sometimes, even in situations where no-till has been used, to break up compaction if it's there and reintroduce fresh organic matter right through the profile. Sometimes that's necessary. You're not going to get you're not going to get a result out of a bottle. It might fine-tune things for you, but the hard work solutions are quite often going to be the best, and several different ones of them. So a multi-point approach is going to be the one that works. There aren't any quick fixes. Thank you.
Thanks, Audrey.
Cheers. Oh, yeah.
Sure, there'll be one or two questions in the room? Yeah.
Audrey, you're very again, you were talking about introducing fresh organic matter and maybe a need to mix the soil up a bit more even in a no-till situation, but I presume cover crops and cover crop roots going down into the soil, that would do as mixing organic matter into the soil.
Absolutely, David. Basically, it depends on, this is the importance of the test dig. I know you don't go out into your field without your spade, so you're a glowing example of that, but what you've first got to do is work out whether any crop residues you're putting on the surface are going to get down into the depths. And there's only one way that you're going to find that out. So if you go onto a field where you've got a cover crop, take test digs, look at where the roots are. If the roots are right down here, and you're seeing earthworms down here, and you're seeing vertical channels, no cultivation is going to be necessary at all. So it's all about the importance of the spade, really. Look at what your soil profile is like. Not necessarily down, you don't need to be going out digging metre deep soil pits every year. You would only do that if there was problems, or you might do that to get baseline data, but your ideal is to let earthworms do the work. But if there are no earthworms, you want to ask why. And if you dig your spade down here and you find that well, which I found on several cover crops last year, they had the cover crop grazed off by some livestock in wet weather, and there was a layer of compaction here. The cover crop roots went to there, and then they were going this way, and nothing was getting down. So it depends so much on having a look, and it's quite often it's just spade depth. And if something's going badly wrong with compaction somewhere along the line, and you've got more evidence of horizontal air spaces than vertical, sometimes cultivation is necessary to kickstart structure formation by moving organic matter down the profile. You shouldn't have to do it. You're absolutely right. You're only needed to do that if something's gone wrong. Mm-hmm.
You mentioned earlier on in your presentation that microorganisms break down pesticide toxicity. So by that you mean AI. Is there any danger that whilst practicing conservation agriculture and our soil biodiversity is increasing, actually the efficacy of because we grow blackgrass as well, so we use step and the efficacy of those residual herbicides will be reduced as soil improves?
So say that again. Do I think that the efficacy of some of the residual herbicides will go down?
Because soil health is improving, microorganisms break down toxicity.
So you're saying, do I think that the efficacy of these residual herbicides will go down because soil microorganisms are breaking them down? No, soil health improves. No, I don't, because I think they'll do what they need to do first. Microorganisms will take a while to break those down. So I'm certainly not seeing any evidence of it, and I don't think that'll be a problem. Yeah? Oh, I see two.
First one, nearest us.
Do you have any experience of a soil test called the Haney test, which is from America?
Yeah.
It uses water to extract nutrients, not very strong acids. It sounded like it made a lot of sense to do that, but it doesn't seem to be available in this country.
Ah, I thought you meant Haney Brinton. You mean water to extract plant available nutrients. Yeah. No, I don't. Bear in mind that, of course, you can extract crop nutrients from soil. It's done differently to organic materials, obviously. When you're testing a dung or a compost, you test total nutrients, total P, total K. So that's dead straightforward. And then you use lookup tables based on experience to estimate the availability of those nutrients from that organic material, such as compost or dung. Soil's done in a totally different way. So when we test soil, it would be pointless to test the total phosphate, or in most situations, I do in land restoration, but that's different. In agriculture, you would never test the total P, total K, or total nitrogen in the soil, because we can't interpret that, because the ability of the soil to give up those nutrients for plants is dependent on so many different factors. So what we've done in all the countries across the world is develop a system, and in Scotland it was done by the Macaulay Land Use Research Institute. In England, I guess it was done by ADAS. Yes, it would be done by ADAS. They develop a system whereby they use an extractant to take some of the nutrients out of soil in a broad estimate of the way that a plant would do it. And the thing is, we're very good at interpreting those results, I believe. Now, I do believe that the Scottish system for phosphate is better for phosphate, and the English system for, I believe that the Scottish system for testing phosphate is better for most Scottish soils, actually probably for a lot of the Northern English soils too. And the Olsen P test, which is used in the ADAS method, is best for, say, more calcareous soils. If you were to start going in and using water, it would also be perfectly useful, but I wouldn't see how it would be any better than the systems we've already got, because we're very, very good, or I believe, we're very good at interpreting those. Now, I do believe there's problems with some of them in some soil types, and you've got to be a little careful, particularly with phosphate. So I don't believe that the Olsen P test for phosphate is good for many Scottish soils. And so Scottish Agricultural College have written a new technical note explaining how to interpret soil phosphate availability depending on the soil phosphate absorption capacity. So it's a very difficult job to do, to interpret test results based on different types of extraction. Some systems are very good, and some systems are not very good. I would be very wary about going across to a water extraction which was based on United States soils, because our soils are very, very different, very different. They've often got a lot less organic matter. Well, prairie soils sometimes have a lot less organic matter in them, for example, and they're chemically very, very different. So the way that we've got the soil test results, soil test methods set up for England, we're very good at interpreting it, and I would stick to that. This is not talking about the Albrecht method, that's different, you know, base, cation, saturation capacity. But as far as straightforward, bog standard, cheap soil tests, I believe that the ADAS methods are appropriate for most English soils and are easily interpretable using the system that we have. And similarly in Scotland, I'm very pro our methods for phosphate on Scottish soils and the northern English soils, because I believe that the Olsen P underestimates the availability of phosphate in Scottish soils and a lot of northern English soils as well, frankly. But I would stick to it because I think it's been well developed for our soils. We moved away from water extraction for a reason. And I don't know about the English side, but I know in the James Hutton, or whatever, it was the Macaulay Land Use Research Institute back then, they felt that the extractant that they chose, which is modified Morgans in Scotland, gave us results that we could interpret better for farmers, and I believe in that.